This is Laura Duncan from CSMS. Today we'll be talking about applications of regressions. Remember that most data collected in real-world situations does not model a perfect linear, quadratic, or exponential function. Though it will not always be perfect, we may even say it's ugly, regression in a calculator can find the line of best fit or the regression for those messy real-world situations. And the purpose of this is to help us understand the real-world information and to help us make predictions. So example 1, it says, remember the panda example? The table shows the relationship between the panda and its age. So let's enter this data into our stat function in our calculator to determine which function it best fits, linear, quadratic, or exponential. Make sure that your diagnostics is on. Now you'll enter the data into your stat function, and there it is. L1 is your x, L2 is your y's. Then let's calculate a linear regression number 4. Press enter, 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 and we're looking for an R value of 99.26. Now let's look at the quadratic function, and we'll compare the R values to see which one is closer to the number 1. This one is 9963, so it is closer to 1. So that means it's going to be either quadratic or exponential. Now let's check for the exponential function. Down to 0. In the exponential function, it is 0.86. So that means this is a quadratic function for sure. Let's take a moment and write down the quadratic function that we found on our calculator. Now that we have our equation, we can use that equation to determine the approximate weight of a 7-month-old panda. Remember that the 7 refers to the x value. So to find the y value, we'll simply substitute the x value into our equation. After entering that into your calculator, you'll find that the y value is 32.94, and please remember to put the label of pounds. Now let's take a look at example 2. The table shows the average tuition and fees at public four-year colleges. Let's take a look at the information first. So as we're taking a look at this, notice that there's an academic year. To make sense of this, I want you to focus on this number right here. If we're looking at the first year, then the cost would be $3,508. And numerically, we can just number the years and make this our x value instead of a year. Now you can enter that data into the stat function in your calculator and put statplot1 and zoom 9 to determine which function it is. However, I like to use the stat function with the diagnostics on. So notice that we have the diagnostics. We're looking for a linear regression. And note that the R squared is 99.198. Now let's look at the quadratic regression. The R squared is 0.9925, so it's higher than the linear regression. Now go all the way down to the exponential regression, which is probably 0. And the R squared value is 0.9907, so that has the lowest of all. So this is a quadratic regression, so let's note that. And if you noticed the regression in your calculator, and we're using the quadratic regression because it had the highest R squared value. Now we can use that to help us make predictions. It says use the line of best fit, well it's a quadratic so it's not exactly a line, to estimate the cost of attending in the 2012-2013 year. So we would say that the x value in this case is 13. Well, if the x value is 13, we're simply taking our line of best fit, or in this case it's a quadratic, and we will simply substitute 13 in for the x value. Once you solve for y, you will find that a good estimate would be $8,752, and since we're talking about money, we would round to the nearest hundredths place, 57 cents. Let's go on to the next problem. Previously, we learned that regression can be used to find the equation or function for patterns and sequences, but not all patterns and sequences are linear, so make sure your diagnostics are on. So when we're looking at example 3, we have perimeters and we have a figure. To find out what's being asked for, we're going to look at the question. Write an expression that can be used to determine the perimeter of the nth figure. Well, when we're looking at nth figure, that really means the position number. So in this case, this is the first figure. So this is figure 1, figure 2, and figure 3. That's going to be our x, or our input value. It's the position number of the figure. So first, second, third, 1, 2, 3. Then we're going to input the perimeter. That's going to be our output. So the output, the perimeter of the first figure is 6. For the second it's 12, and for the third it's 20. Then please input this into your stat function in your calculator and find out if it's linear, quadratic, or exponential. Please pause the video here as you do that. Now that you've found that this is a quadratic regression, it asks what is the perimeter of the 7th figure? Well, the 7th figure is talking about the position, so that is the x value. So simply input the x value into your expression. So we'll have 7 squared plus 3 times 7 plus 2 equals 72 inches. So for the 7th figure in this sequence, the perimeter of that figure will be 72 inches. Let's look at letter C. Write an expression that can be used to determine the perimeter of a figure with n sides. Well, you might be wondering how that's different than what we've already done. Look at A. It says write an expression that can be used to determine the perimeter of the nth figure. So in this case, the y was perimeter and the x was the position number. This time they want the n, or input, to be the number of sides. And for the output, we're supposed to be determining the perimeter. So that would be our y value. Our perimeter hasn't changed. It's still 6, 12, and 20. However, now we need to determine the number of sides. So go back to the first figure. It has 3 sides. This one has 4 sides. And this one has 5 sides. So that will be our input value this time. 3, 4, and 5. Now using your stat function, please determine which regression would most fit and write down the expression. Please pause the video here. So again, we found that it's a quadratic regression and the expression would be x squared minus x. Now they're asking what the perimeter of the figure would be with 7 sides. That is the x value. So we'll simply put in the x value, substitute it, and find that if it has 7 sides, the perimeter of the figure will be 42 inches. Now let's look at the last example. Mrs. Anderson's students occasionally play math poker. Each student starts with $100, play money of course. Each round, students bet money based on how confident they are that they can get the next math problem correct. When students get a question correct, they can add the amount of their bets to their totals. Bryson, a very confident student, decides to go all in each round. The table shows his earnings after 3 rounds. If Bryson continues to get questions correct, complete the table for rounds 4 and 5. And B, write an equation that can be used to determine his earnings E after R rounds. So please start by putting this information, the information that you have, into STAT. Find out, using rounds as your X and earnings as your Y, which regression best fits, and then please write down your regression. Pause the video here so you can do that. Alright, I hope you found that this was an r-squared value of 1, which means it is perfectly exponential. So this is the expression or the equation we have since there's an equal sign. And we can answer the last question. If Bryson gets every question correct, how much money will he have after 15 rounds? Well, the 15 is the x or the r value. So we simply input the 15 into our r value, and then we find that he would be a millionaire. Now we can go back and do the same thing for the table. Input the x or the r value as 4, and you'll find that he has $1,600 and then $3,200. Or you can simply follow the pattern in the table to find that out as well. The lesson is yours.